Hi, my name is Corey Freed, and I am the Educational Consultant at Visual Sound. Today we're going to look at a couple of different projects that you can use for remote teaching that work for any environment, whether you are all physically in the same classroom space or working asynchronously through web conferencing software. These ideas can all be incorporated into different environments and different subject areas. Some of these activities will require facilitation by the teacher, while many of them will be able to be used remotely without a teacher present to help assist. The first thing I want to do is look at what exactly is STEM education. So depending on where you are in the country, STEM education has a lot of different acronyms, but at the end of the day, the education is the same. STEM is all about the cross-curricular activities that allow your students to see those real-world and project-based lessons rather than just memorizing facts out of a textbook. This is going to help them prepare for the real world where they're not going to have an A, B, C, D answer choice, but may actually have some trial and error to find the best solution for their problem. Most teachers, when they think of STEM education and makerspaces, they immediately refer to 3D printers. This is great if you have access to one, but what about when your students are working remotely? They're not going to have a printer readily available in their home, so we need to find other solutions that they can use to learn these 3D concepts, to learn prototyping, to learn CAD software, and to have fun doing it. So what we're going to look at right now is an example of some ways that you can do 3D design without being physically present with a 3D printer. This is one of my favorite activities to do with students. It is this Recycled Olympics. What you're going to do is you are going to give your students the directions to use only recycled materials to create a carnival game. Then the students can come and play those games. Some schools have actually turned this into a fundraiser on Earth Day, where the students create the games and then family members can come pay a small fee, maybe 25 cents or $1, to play the games and actually use the recycled materials. A good example of a game using recycled materials is a ring toss, where perhaps the students are going to use recycled soda bottles for the targets, and then they can take a hanger and make it into rings. These type of ideas are using, again, nothing but recycled materials, and it's a great way to show students the design process, being green, and all of these other concepts that are great for education. What I would like you guys to do right now is pause this video and see what kind of games you can come up with. If you don't have any materials, please feel free to just draw out a diagram, because that's another great way to allow students to use what they have available. Welcome back. So what kind of game did you come up with during that pause? How do you think your students can share their final projects with each other? There are a couple of different ways you can do this depending on your LMS and your school's policies. You can let your students upload a picture of their game to their LMS along with a short description or summary of what they designed. Another great option is to use Flipgrid.
Once you've signed up, start the discussion by creating your first topic. Your topic can reflect on a chapter of reading, demonstrate an exercise routine, share a hypothesis, anything. I'll make this as simple as share one of your favorite discoveries. Add anything you want your learners to review prior to responding, such as links and videos, to foster enriching inquiry. You can also set the maximum recording time and choose to moderate your topic, meaning video responses will be hidden from your community until you approve them. Your topic is private to your learning community. Add the email domain of your learners, that's everything after the @ symbol in their email, or create a student list for younger learners. Add a guest password if you want to invite families or experts into your discussion. When you're ready, share with your learning community. All they need is this unique code.
Let your students create a 30-second commercial advertising their game, why you should want to play their game, and what materials they use to build it. They can then watch each other's commercials and comment on them. So that's another great way to engage your students and let them collaborate by using Flipgrid videos. So what happens when your students don't have access to the internet or a computer in general? Unplugged activities are a great way for students to work on their computational thinking without requiring any technology. Computational thinking is basically the way that a computer thinks. Computers have to read directions from top to bottom, and they can't deviate. So what happens if you give a direction and you don't give it clearly? The computer won't know how to read the code. Same thing with directions for a human. A great example of computational thinking is a recipe. When's the last time you baked cookies? Did you ever notice the directions always start with something so simple? Preheat the oven. So what happens if you put those cookies in the oven before the oven's preheated? The dough's not going to cook the same way. It might be too chewy, or it might be too brown. It might end up still being raw and you have to cook it longer, which in turn gives it a different texture as well. What about the actual directions? Ever notice they always recommend mixing the dry ingredients and the wet ingredients separate and then combine the two once they're mixed? What happens if you just pour everything in the bowl? The cookies are going to come out different. This is all great examples of how your students use computational thinking every day, even if they don't realize they're using computational thinking. What we're going to do now is another one of our little activities. I would like you to write directions on how to make a paper airplane. When you write these directions, make sure they're step by step exactly what needs to be accomplished. If you have a colleague with you working on this webinar, trade directions with each other and try to build each other's plane. Hit pause and come back when you're ready. Welcome back. So how'd your planes come out? Did they fly straight? Did they twirly? Did they not go at all? These are the type of things that you have to realize when you're reading directions. Little tiny things can cause them to go off. In a code, putting a period instead of a comma can mess up the entire computer language. Such little things seem silly, but they're really important, and this is a great reason to use these type of unplugged activities with our students. Let them see the things that they do every day and then relate it to computer coding, which is a great tool. So let's talk about coding itself. You don't necessarily need robotic products to teach coding because many coding programs are based on the computer. One of my favorite languages to start with is honestly HTML. I know it sounds silly, but it is an easy language to learn with fast rewards. Most of us have seen that first code that everybody tries, hello world. Why do we just do 2 words, hello world? Well, again, simple code to write, quick rewards. You can then move on to a little bit more advanced. Change the color of the font, change the size. Very simple things just to get kids started on how code looks and how code works. Make sure you're using brackets and not parentheses. Make sure you are closing your comments. All of these things seem so silly, but they really can change the code. So if you are going to teach coding and you do not have anything more than the computers, HTML is great because they can see the results directly on their screen. So what if you do have products? First thing we're going to look at today is SAM Labs. SAM Labs are Bluetooth-enabled little blocks that have different functions depending on the block. The really cool thing about SAM Labs is you don't actually need the pieces with you to practice the coding and see results. SAM Labs has their own software that is called SamSpace. Within SamSpace, you can see virtual copies of the blocks and you can code them, connect them, and see the results of how your code works. Once you're back in school, you can then take that code and connect it to the blocks so you can see what the results really look like. One of my favorite things about SAM Labs is that they come with Lego adapters. So you can build anything out of Legos, attach the SAM Lab blocks, and now you have this amazing project that has all this interactive function using code. Really cool thing that you could also do with it is in your CAD software, 3D print the design, leaving space to put the blocks in once it's printed. So what your students can do is while they're home, they can write their code, they can make their design in CAD software, and when they come back to school, they can print out those designs, attach the blocks, and see a final project. SAM Labs knows that, again, not every student is going to have the equipment at home. So they've been working really hard to design their curriculum on that virtual block system so that students can practice and code and have all these other things that connect to it without having the physical blocks. What you are looking at right now is the SAM Labs virtual classroom. This was built in Google Slides, which means any internet-enabled device can access it. As you notice, there are little links embedded within the images so that you can branch out from the classroom to all of these different activities. One of my favorite things that SAM Labs has done is they have actually found read-alouds for different books on a STEM topic so that you can branch out to YouTube and show your students these videos. They have books for different age levels and they have slides for different age levels. So check out the virtual classroom and see what you can use with your students. You're also going to notice that some of these activities are grade level. So you'll see they have kindergarten lessons all the way up to 8th grade lessons. Again, this is going to depend on your needs, but you will be able to find the materials. Virtual reality and augmented reality are another 2 words that you hear a lot when you're talking about STEM education. Virtual reality is used mostly for field trips, and this is a great thing during remote learning because you can send your students to these places that they've never had access to or that on a normal day there's no time to see. But using these virtual field trips, your students are able to explore and they can then go back and create new things. Additionally, you have some options that are not virtual and would just be on your screen. Local zoos and museums have been doing these field trips for a while now, where you can connect via Skype to a classroom and see the places if you're physically there. The tour guide will take you around via the camera and let you experience the museums and the zoos, all of these type of places. Augmented reality is a totally different beast. With augmented reality, you are seeing the real world, but you are bringing in digital concepts. Z-Space is a great example of this because when you put on those 3D goggles, you can pull things directly out of the screen and look at them. They also have a laptop version that you can send home to your students. A great thing about this as well is if you are sending devices home to your students, Z-Space computer laptops are Windows 10 devices. What that means is your students can use that Z-Space laptop as a regular computer. They can access their Microsoft tools. They can access their Google Drive. Anything they're using on a computer can be accessed through the Z-Space. The benefit of the Z-Space laptop is you also have all of that augmented reality functionality. The Z-Space computer comes with 3 cameras, the traditional one on top and 2 on the sides. It then also refers to a stylus instead of a mouse, because your students will use that stylus to pull things out of the screen, dissect animals, build things, whatever they can do, Z-Space allows it. I personally like Newton's Playground because it lets you explore all of the physics of the real world safely on your screen. You could also then take those same experiments and move them to another planet. Tired of Earth's gravity? Check out Mars. The really great thing about that is, again, those real-world connections. Remind your students that astronauts are currently training for the first mission to Mars. Are they prepared? Z-Space also has the studio. In the studio is where you can do animal dissections, you can see historical creatures and historical objects. Take it out of the screen, look at it from 3 dimensions, and actually experience it. Thank you for joining us today as we looked at ways to bring STEM into the classroom while teaching remotely. I hope you got some great ideas out of this, and I hope you found some resources that you didn't know about before. If you have any questions, don't hesitate to reach out, and I am here for you to help you succeed and to help your students succeed. Have a great day.